Well, good. Where are we? Good afternoon, everyone. At NRAO, it's good to see everyone online again. Welcome to the next in the series of presentations by ODI about the work being done within the Office of Diversity and Inclusion within NRAO. Some of you would have been attending our previous talks where we've highlighted, the different projects being done. And it's my pleasure today to, pull together the team to talk to you about the work being done by the National Radio Dynamic Zone project. Listening to all hand talks by Tony, also just, looking at newsletters. I think you will have noticed that spectrum management, radio spectrum management is becoming something more and more important, in terms of work being done by the observatory. And of course, it is very important to the work that we do and the science that we do. So how we will work today is I will just introduce the team. So we are being joined by National Radio Dynamic Zone Project Director Pree, who will kick off and just give a brief overview of the NRDZ project. And then he'll hand over to Valarie Bogan, my colleague within ODI, who's our curriculum specialist within the National Radio Astronomy Observatory, who will talk to you about the broader impacts work being done within the NRDZ project. And then finally, I will wrap it up and just tell you about other spectrum work being done within the NRAO for broader impacts. So handing over to you, Chris. Thank you.
Great. Thanks a lot, Anja. And thanks everyone for joining today for the launch talk. I think we can move forward to the slide where I'll just sort of mention the team. So as Anja mentioned, I'm the project director for the National Radio Dynamic Zone project, NRDZ, as we fondly call it. And I'm also the deputy spectrum manager for NRAO. Randy Arnold has just joined as project manager. You may have remembered Casey Miller, who was part of the project for its first year plus, and we're really happy that Randy is on board. Kevin Shoemaker and David Bortnave are engineers over at CDL. Kevin is our lead engineer, and David joined the project just in the past, 6 months, I guess, and has been a huge contributor. And there are a number of other unofficial parts of the engineering team, of course. CDL is a big team, and there are many contributors to the engineering effort. Anja is our leader for broader impacts at the observatory. And then, of course, Valarie is the curriculum specialist who's going to be doing most of the talking today. All right. So yeah, you may have heard the term National Radio Dynamic Zone, and basically the idea is to provide a place for passive and active users to kind of figure out how to increase spectrum usability, right? And the purpose of a zone, which we hope will be a physical space, is to really pilot some new technologies. And NSF is very supportive of this idea as an agency. There are lots of ways in which this is needed, but we need it to help us, right? So as radio astronomers, we want to preserve spectrum and spectrum use and not get swamped by all of these active users. And so NRDZ as a location should help us support the design of our next generation of receivers on our side and transmitters, right? That in addition to sort of real-time coordination, perhaps we can actually make some technical innovations to allow coexistence. And then, we really want to preserve passive uses of the spectrum. We often benefit from the fact that there are passive uses of the spectrum like Earth monitoring systems where the economic impact is very dramatically evident. Radio astronomy, sometimes we have to make more of an argument, but if you don't know where that hurricane is, that is a problem, or if you can't predict its trajectory. Okay. So the NRAO got a 2-year grant with some specific deliverables. They're outlined here. Concept definition and stakeholder development is basically trying to develop the idea of what an NRDZ could do, along with input from a lot of different people. The ASM, you've probably heard some about. This is our actual physical device, which we will be interested in using both to monitor sites and also to monitor an eventual NRDZ. And then, of course, the important work you'll hear about today is broader impacts, educational materials, workforce development, all related to understanding of the spectrum and of radio astronomy's role within the radio spectrum. So some quick status updates. There's a paper that was accepted in December called Radiodynamic Zones, Motivations, Challenges, and Opportunities to Catalyze Spectrum Coexistence. This is work that I've done with Chris Anderson at the US Naval Academy and Maria Zheleva, two wonderful colleagues who, although they are users of the active spectrum, are very nice people. And we work very well together. And we have pulled together for workshops, 75 to 100 people, and for these smaller events called lean coffee table events, more like 15 to 20 people. And actually, we just found out yesterday that there's a website called The Conversation, which has accepted our pitch for a popular article on the same topic. And so that is a short article that will steer to other articles, but it's a really cool website if you've never seen The Conversation. So we've done 3 of these workshops, we've done 7 lean coffee table events, and we've provided actually NSF with the feedback from those early events to do a second call, which we responded to, and we have been funded actually for continued NRDZ money. There have been NSF-sponsored spectrum events, which we participated in, and I'm working with Chris and Maria and GBO to plan a face-to-face meeting in September, which will be a sort of capstone for this concept definition work. The ASM, this is the one that gets the pictures because it's an actual cool thing. So here is the mechanical blow up and also our first enclosure, this is an early picture, right, when it was delivered. But if you go to the next slide, we are in the process of doing some early testing. This is some nice software that was developed by David Bordenave that shows an initial test at some low frequencies, showing the format of the eventual GUI that we hope that the ASM will have, where we have spectral plots down at the bottom and information, diagnostic information over on the upper right, your requested spectral spans over on the upper left, and then that central plot is part of the direction finding capability of the device, where we hope that you'll not only be able to know power, frequency, bandwidth, but also direction to your source of RFI. And if you go to the next slide, I think we have, oh, okay, so this is status. So we've built the enclosure. We have a couple of the high frequency horns. The converters monitoring control system is operational, thanks to the hard work of Kevin and David. Switch assemblies and the remaining horns and sinuous antennas are being machined and constructed. And as you saw on the previous slide, David has built the initial software for spectrum analysis and direction finding. Building a thing during a pandemic is hard, right? Just getting people into the lab is hard. Finding parts and pieces is hard. We don't have a lot of capabilities for full system tests, in particular horns and antenna testing. At CDL, we have some capabilities, and we're complementing those with some capabilities at Green Bay. And the plan, sorry, one last thing on the previous slide. The plan is to build and test ASM1 and then have a preliminary design review where we look for things that we can improve for the second and third devices. So we are funded to build 3 of these. Okay. And then finally, I think this is my last slide. Coming soon, we did get funding for sort of a next wave of NRDZ work called Dynamic Protection and Spectrum Monitoring. The Area 1 study, you may have heard about the testing that we're doing with SpaceX, right, where we're trying to look for a way to cooperatively use a part of the spectrum that they are licensed to use. So they're playing nice with us in a part of the spectrum that they wouldn't necessarily have to play nice with us. So we have been taking data in that area, and so the Area 1 study will propose an actual software and hardware solution for cooperative use of spectrum, in particular in this one case with a satellite operator. And then the Area 2 study, which is funded under the same proposal, is improving the direction finding capabilities of the devices that we are currently building. And then there's important broader impacts, which is a very nice extension of the great broader impacts work that you're going to hear about today from Valarie, where we will push into an RFI-related citizen science project, which we think there's a lot of interest in, and also the development of a display that we hope could be functional near an observatory, right? Ironically, we want to have a display of RFI that won't create RFI for an observatory. So that's part of that. Okay, and now we get on to the real part of the show. You've seen an overview of what we all are up to in the broader project, and I'm happy to introduce Valarie to talk about NERD's broader impacts.
Thanks, Chris. I'm happy to be here. So the broader impacts part of the NRDZ project has many components. The first of which was the high school curriculum. That's what we got started on first. So I developed 6 inquiry-based lessons that use an RTL SDR dongle to allow students to visualize the radio waves that are going through classrooms. So the names of the 6 lessons you can see on the screen. These are inquiry-based, so it gives students an opportunity to really interact with the spectrum and get a deeper understanding of all the uses and why it's so important. Next, please. But what was found was that a lot of students really lack the background knowledge to make them successful in understanding these more advanced topics. So I also developed 3 scaffolded lessons to give the students the knowledge they need to be successful. So things on very basic mechanical waves, electromagnetic waves, and the electromagnetic spectrum. So that once they understand those, then they would be able to understand the other lessons. And these are all available for teachers, and they're not at all expected to use all 9 lessons. So they can pick and choose among what exists and use what makes sense in their classrooms. Next, please. So during the summer of 2022, after the lessons were developed, we recruited 24 high school teachers from Virginia, West Virginia, or New Mexico to participate in a professional development. This was held asynchronously due to the ongoing pressures of COVID. So they were all asynchronously involved in this training. It also gave them the flexibility to do it when it made sense for them. They went through direct instruction on each lesson through a series of videos. The videos told them how they could teach the lesson in their classrooms, gave them tips on pedagogies. And then they reviewed all the materials and were given a chance to have some social interaction with their other members of the cohort through discussions about best practices. And we focused on culturally inclusive and responsive elements in teaching. Each of the 9 lessons has suggestions about how teachers can make these lessons better for all of their students. So really make everyone feel welcome in this space. But we also had discussions that allowed the teachers to express their own opinions about what worked well in their particular classrooms, or maybe what they struggled with when it came to being culturally inclusive. So at the end of the training, all the teachers were given the tools that they needed, both professionally and physically. A kit was sent to them with all of the physical things they needed so they could implement the lessons in their classrooms. Next, please. Thank you. These, like I said, these lessons are all available to any teacher who would like to use them. It's on Supernova. You can see the website there. And when a teacher goes to Supernova, what they see is an example of what they will see is on the screen in front of you. So this is the mechanical waves. It gives them a small description of it, and then they're able to download the pieces that they need. The things that are for teachers are in blue, like the lesson plans or anything that they're going to need from their side, while all the student materials are in green to help them to figure out which pieces they need. And all of those are downloadable so they can use in their classrooms. The second piece of the broader impacts section of the NERDS project is the citizen science project. So this was intended to give all citizens, all people, an experience with the electromagnetic spectrum and understanding how much we really use it and how much we really depend upon it. This uses the same RTL SDR dongle that is used in the high school curriculum. and allows the people to just visualize the radio waves that are traveling around them. Currently, we only have 3 activities available through this project, although this can be expanded later. So they are able to identify local RF broadcasters, they're able to track aircraft, and there's a extension activity where they can receive satellite signals, because that would require them to build a better antenna than really comes with the RTL itself. So you can see a picture of what you will find on the Citizen Science Project page. It explains the activity. It gives them an idea of what kind of things they need to do before trying this activity, as far as downloading software, and directs them to guides they may need to look at. There's a technical guide, and then there is a place for them to upload some data. So they can upload the data, and then the leaderboard is to keep track. Everybody likes the competition, and so we're going to recognize the people who have uploaded the most data, and they get to be present on the leaderboard. There's no prizes associated with it at this point, just a feeling of, hey, that was me, and I made a contribution to this project. So for some future plans for both the Citizen Science and the high school curriculum, so the Citizen Science Project is going to be expanding in the next couple of months to include some activities that people can do with cell phone apps, because we want to make this accessible to everyone, and not everyone has one of those dongles, and not everyone has the skills to make that software work with a dongle. And so by adding some things they could do with their cell phone, they can still participate, they can still develop a better understanding of our use of the spectrum and be part of the project. Also, we're going to try to partner with a group called SciStarter. It is basically a repository for citizen science projects, and they actually have a program, because the projects associated with that particular page have people collecting data. And so they have a promotion where they can actually win points and get some prizes for uploading data to the projects. So that will allow us to actually offer incentives for people to upload instead of just having our leaderboard. And as far as the high school curriculum, there's going to be some advertisement coming. I'm going to be attending the NSTA, that's the National Science Teachers Conference, in Atlanta in March. And I have 5 different sessions. 4 of them are on the curriculum itself and on Supernova, while the other last session is actually on the Citizen Science Project. And so my plans are to have the cell phone activities by that conference, and then start working on the SciStarter partnership. So the last piece of the broader impacts is the undergraduate curriculum. So I'm developing a course called the Introduction to Spectrum Science and Management. It can be a 3-credit course if you use all 6 modules together, or each of these 6 modules can be used individually as part of an existing course. So on the top right-hand side, you see Steve Ellingson. He is a professor at Virginia Tech, and he wrote both the science fundamentals as well as the engineering fundamentals modules for us. Below Steve, you see now, of course, you forget their names when you're looking at them. Lisa Sockett. Lisa is a former FCC chair, and she is a professor at George Mason Law University, and she wrote the Legal and Regulatory Foundation of Spectrum Management. And underneath of Lisa is Sarah Lamb, who is a senior fellow at the Technology Policy Institute and wrote our Spectrum Economics and Market Tools. She, interestingly, is also a former student of Lisa's, so we have some interaction going on there. On the bottom, we have Dennis Robertson and Roger Peterson, who work for Robertson and Associates, which is a spectrum consulting firm in Chicago. And they wrote the Management Methods course. And then finally, just to their right on the bottom is Ed Murphy, who is a professor at UVA, who is creating our radio astronomy and the spectrum module. So the plans for our undergrad course, the first draft is currently being finalized, hoping to pilot it this summer, and then we'll do some revisions, and then it will be ready to use. And the purpose of this course really is to get more people in general interested in pursuing careers in the spectrum professions, but particularly those who go to MSIs, get them a chance to take courses that are not maybe available at their institution and give them some additional job prospects. And that is the end of my portion. So now I'm going to turn this over to Anja.
Thank you very much, Valarie. Yeah, I think just to talk a little bit about, NRDZ phase 2, as, Chris had said earlier, there will be, a NERDS phase 2, as we call it, or a second proposal for NERDS. And as you can see, in that population focus, we'll be looking at K-12 undergraduate, and then also looking at graduate students through the museum, museum exhibit, which Chris talked about, looking at interns to do research and training experiences with the NRAO as part of the summer school. We're looking at an extension of the citizen science project using the Zooniverse interface. And then finally, looking at expanding the courses that we've done into graduate curriculum as well. So looking at a certificate there. So an incredible amount of work already done by Valarie. Thank you very much, Valarie. It really, it's been an incredible amount of focus and collaboration with our content specialists to get this work done. And what I wanted to, overview or just outline for you before the end of the talk is just how exactly this work fits in with some of the other spectrum work that you've been, broader impacts work that you have been hearing about. And so, just starting with the other project which we have within the Office for Diversity and Inclusion, and that's the ham radio and the electromagnetic spectrum project, which is being funded by the Amateur Radio Digital Communications, otherwise known as the ARDC. And this is a 2-year project, which is being funded by ARDC, where we're looking at really engaging BIPOC and LGBTQIA+ students to learn more about the electromagnetic spectrum, and then, of course, the excitement of amateur or ham radio. That project, you may have, attended Jesse's Alexander's talks at the end of last year, but that essentially, consists of 2 cohorts of 10 students for 20 weeks each. And in that, time, we look at introducing students to the MSE, to the electromagnetic spectrum and radio technologies. Jesse has developed an incredible sort of scaling and, scalable and shareable curriculum, working with Valarie, to get that onto Supernova. And then, the whole intention of this is to make sure that the students get hands-on activities to deepen the subject knowledge of the electromagnetic spectrum and amateur radio. And the intention at the end of, the 20 weeks is to make sure that these students actually walk away with a technical and general class amateur radio licenses. So very exciting work happening through the ham radio and the EMS project. Then we are also a collaborator on the Spectrum X Center. This is an NSF Spectrum Innovation Center, the first of those. And the work that's being done here is also being done by Valarie, really being project managed and driven by her. And that exists, it consists of also middle, and high school curriculum. So at this stage, Valarie has already, hosted an educator residency for 10 middle and high school educators that was held over the summer last year. And in that residency, teachers developed 20 additional spectrum-related grade 6 to 12 lesson plans. So in addition to what's been developed for NRDZ, we have now, with these educators, developed an additional 20 lesson plans. And none of this is, duplication. All of these lesson plans are complementary to one another. And so, we essentially have about 30 lesson plans ready to roll for educators in middle and high school. The lesson plans that were developed through the Spectrum X work is currently being prototyped not only by the educators who developed them, but also we are working with the University of Puerto Rico, Mayaguez, and their QUAB project, which is their university Center for University Access, which runs, afternoon sessions for high school students as well as summer camps. And they've kindly agreed to work with us, on prototyping those and hopefully translating those into Spanish. And at the end of this all, of it all, what we'd like to do is to train 28 educators in the use of these lesson plans. And we would like to focus on, 2 educators from one of, a feeder school from the radial institutions or our radial minority serving institution partners. Another project being conducted as part of Spectrum X is the Broadband Map US. This is a collaboration that Jennifer Bates is running with 3 of our radial minority serving institutions. And in this project, students can use an app, on a number of different types of smartphones. And what they will do is to actually, as they, go, on their daily routines or just, get on with life, they're able to collect data around their campus or around their environment on 5G, CBRS, Wi-Fi. And eventually all that data, they actually have the app on the cell phone. Data is, collected, it's curated, it's cleaned, it's extracted into files, it's analyzed. And so we can have a look at the spectrum occupancy and the usage in different bands in the areas that they're in. And that data will then eventually be shared with the NTIA. And this is a great way for our students to gain knowledge of the deployed wireless networks, measurements, and of course, we want them to be able to analyze data. And then finally, the Citizen Science Project, again, complementary to the NRDZ project. Essentially, NRDZ, the deliverable for us there was to develop the project and to prototype it in the classrooms, as Valarie explained. And what Spectrum X is allowing us to do is, in fact, to expand the activities that we may be able to do with a kit and to start distributing these kits to schools and to the general public from next year onwards. We're looking at about 100 kits per year just to start. Also, the development of a science center portal or the support of such a portal. And then to end off, in financial year 26, once we've, managed to look at the data, to work with, and if any of you are interested in working on this with us, you're welcome. Looking at a public event, a type of hackathon or whatever event it is that we design using the data that we've been able to collect through the Citizen Science Project. So that brings us to the end of the presentation about the broader impacts work for the NERDS project, and we will open it up for questions. Okay, so question from Heather Cochran. Hi, Heather. Will any of the curricula be highlighted on the main NRAO site? I'm going to hand that one to Valarie.
I mean, that would be great. There aren't any plans at this moment to do so, but I'm happy to entertain doing that.
Yeah, it will certainly be on Supernova. I imagine a link from the NRDZ website, but yeah.
Yeah, I think the current NRDZ site, or the current Spectrum site that has an NRDZ tab, does link to the Supernova. So those curricula are linked.
And I just want to add for the Citizen Science Project, because I know a lot of people at NRAO, like they have, SDRs at home and they like to do those kinds of things. There's also the opportunity for you to suggest how we expand that project. So right now we have the 3 activities I spoke of, but if you go to that page, which has been linked in the chat, there's also a place where you can submit new ideas. So I know for those of you who, like I said, do like to do that, if you have additional activities that work really well, I would love to hear about those. Feel free to send those either through email or through that opportunity on the webpage.
Just to, to build on and support what Valarie is saying, we are constantly looking for content specialists, mentors, spectrum experts to help us do the work that we're doing within ODI, whether that's developing content for the courses, whether it's, being able to help us go through or prototype some of these lesson plans. If you are a ham radio enthusiast, helping us to find mentors or being able to give input as well. So there are always opportunities available for collaboration with ODI, and we greatly appreciate them, and we need you. Okay, so question from Bung: will this overlap with the summer REU program to some degree? I think the overlap specifically for nerds, Chris, you can correct me if I'm wrong, is that one of these students, we do have funding for a student to do what we call a research and training experience with the nerds team. Last year we had 2, thanks to additional funding from Tony. So I think that, that's probably the largest overlap that we have. Specifically for nerds, I think for the Spectrum X from year 3, which is next year, 24, we will have 8 positions available for students from minority serving institutions to work on spectrum related research.
Yeah, that's exactly right. So we had 2 students last summer, Nathan Sparks and Clive Binu, who Clive was presenting actually at AAS just a week or so ago about the VLA testing of the SpaceX downlinks. Nathan was working on the Green Bank sort of side of that same project. So yeah, I think we're hoping to continue that type of work with students in the coming summers for sure.
Right, and it's just to say that the work done by those students this year was incredible. They did a really great job at the AAS. And Chris, do you want to just have a quick word or just say something quickly about your session at the AAS?
Yeah, so there was a special, not a special session, but there was a poster session on RFI work, and GBO and NRAO were very represented there. We had I think 6 posters altogether. There were posters highlighting the RFI GUI that's being developed at Green Bank, which is really cool. There was a poster that our new NRQZ program administrator Sheldon presented, which was a great overview of how the NRQZ operates. We had one on NRDZ. Clive had a poster. So yeah, we had a number of, as I said, we kind of dominated that session, which shows that, NRAO and Green Bank are really working hard on these issues. And that was a nice way to highlight that. And we weren't standing there alone. There was a lot of interest in all of these sessions, which was great. And we also got to meet some folks from sessions on the previous days who had built a simple radio receiver. I sent that on to you, Valarie, those contacts. There's a great group at Winona State, I think, that was developing a receiver that high school teachers were going to be able to build on their own. So yeah, there's a lot of great work going on. And, I think nationally people do look to NRAO as sort of a collection point for a lot of this information, but there's good work going on at a lot of places.
Yeah, and I think, leveraging that national role that we have is a great introduction to, well, for the answer to the next question from Ben Casto, who says, will the educational program be available through community colleges or will it only be through universities? So Ben, the reason that we started developing Supernova, and certainly, one of the principles and the values that we have within NRAO and ODI is, certainly equity in STEM education and accessibility, and, being able to remove as many barriers as we can for students. So the model that we follow is, we receive funding to develop the courses. So whether those be the undergraduate or the graduate courses, these are asynchronous. So they are available on Supernova. So students are able to go in and do these courses themselves as a certificate. However, any community college, university is allowed to use the content that we have produced and to present it as part of their course material if they are willing to, get it through their curriculum approval panels, which we help them to do with, the fact sheets that they're required to produce at those reviews. And as long as they're willing to put it, to have a teacher of record at that institution. So, we want to get this into as many hands as possible. Okay. Any other questions?
I'll just add that was a great summary, but having just come out of an undergraduate institution where I was for the past 25 years, that hurdle of getting things through curriculum committee can be onerous. And so any sort of support that we provide on that front is great. And yeah, as you said, the only limitation to use anywhere is really the institution itself, right? So other institutions just have to accept this as a curriculum. But I think that the work, Valarie, you've done will certainly make this a pretty dynamic curriculum that I bet, that's the idea, right? That this is a need that is not being filled at a lot of colleges and universities right now. And so that these new modules really will be value added and people can pick these up.
Yeah, it's a good point, Chris. And I think so often, these curriculum approval panels or even just a faculty member can actually be a hurdle to access for a student. So if a university or a college decides not to, present that particular course, there's Supernova. And that's why we want to make it available to them there, even if they may not necessarily be able to have credit for it. They can get the certificate. But just to say thank you very much for joining us as we continue to provide you with an overview and explore the work that we do within the Office for Diversity and Inclusion, and of course in the NERDS office. Thank you, Joel. Thank you for your enjoyment. And please reach out to Chris, myself, Valarie, just search in that email inbox. Our names will pop up. If you have any interest in working with us, or if you have any other question about the work that we do through NERDS or for broader impacts at the NRDZ.